Example 4 is modeling with exponential equations. Wood is a sustainable, renewable, natural resource when forests are managed properly. One lumber company has 1,200,000 trees. They plan to harvest 7% of the trees each year. How many years will it take to harvest half of the trees? So, we know where they start off with. We're going to use our A of t equals A1 plus r to the t power formula from a couple sections ago. We know that they start off with 1.2 million trees, so that's going to be our A value. We know they harvest 7%, which means it's subtracting 7% as a decimal is 0.07. And we want to know how long it's going to take for them to have half of the trees, which means half of their original amount, which is half of 1.2 million or 600,000. We can simplify a little bit here. 1.2 million times 0.93 to the t power equals 600,000. Divide by our A value. One too many there. Divide by our 1,200,000 there. We get half equals 0.93t. Before, when we did these problems, that was all the further we could go. Now that we know about logarithms, though, we know that anytime we have a variable in our exponent, we can solve it using logarithms. And in order to do that, we're going to take the log of both sides. So log of 1/2 equals log 0.93 to the t power. T we can swing. Log of 1/2 is the same as log of 0.5. Half and 0.5 are the same. 0.93 for our log. We have multiplication. To get rid of multiplication, we divide. So we're going to divide by log of 0.93 on both sides, which is going to give us t to be approximately, again, make sure when you type these in, log 0.5, close that parenthesis, divide by log 0.93, and we're going to get about 9.55 years. So a little over 9.5 years. We could plug that back in to check if we wanted to, and it should give us approximately 600,000. Example 5 is solving a logarithmic equation. What's the solution of log of 4x minus 3 equals 2? So when we had exponentials with a variable in the exponent, we had to use logarithms. Now, when we have a variable inside our logarithm, we have to use exponential form. We take our base. When there's not 1, it's 10. So again, that's called our common logarithm, and it's base 10. 10 to the second power equals 4x minus 3. That's how we switch to our exponential form. 10 to the second power equals 4x minus 3. 10 to the second power is 100. Solve for x by adding 3. Dividing by 4. And x is going to be 25.75. Go ahead and try this one. Again, we have our common logarithm here, base 10. So whenever we have a variable inside our logarithm, we have got to switch to exponential form. 10 to the negative first power equals 3 minus 2x. Our base exponent equals. That's what our equals is. 10 to the negative first power is 0.1, equals 3 minus 2x. Subtract 3, negative 2.9, equals negative 2x. Don't forget here that the sign goes with the number, so it's a negative 2x. Divide by negative 2, and we get 1.45 equals x. Example 6 here, using logarithmic properties to solve. One thing we have to remember when we're solving logarithms is that our domain is restricted. Our domain is only positive numbers. So we have to double check our answers, because once we plug them in, sometimes we're going to get extraneous solutions. So it's not necessarily just going to be because x is negative, it's when we plug it back into the logarithm. So double check on all of your logarithm problems to make sure that it's actually in your domain. When we use logarithm properties here to solve, first thing we're going to do is simplify each side. So I have two logarithms here that I'm adding together. So I'm going to rewrite that by multiplying my values here, my x minus 3 and my x. Because we're adding, I rewrite those as multiplication. I can distribute that, and I have log of x squared minus 3x equals 1. Now that I have one logarithm, I can switch it to exponential form to solve. I can't solve here without switching it to exponential. Again, it's a common logarithm, so our base is 10 to the first power equals x squared minus 3x. 10 to the first power is 10. It's a quadratic equation, so we have to get it set equal to 0 before we can solve. So I did that by subtracting 10. Now I need things that multiply to 10 and subtract to 3, which are 5 and 2. 5's bigger, it gets the sign of the middle term. Opposite signs there. So we get x minus 5 equals 0, or x plus 2 equals 0, x equals 5, x equals negative 2. When we go to plug these back in, 5, we have log of 5 minus 3 plus log of 5 equals 1. That one's going to work out just fine. We get log of 2 plus log of 5 gives me log of 2 times 5, log of 10. And we know that base is 10 of 10 means it's just 1 equals 1. That checks. When I go to plug in negative 2, however, log of negative 2 minus 3 plus log of negative 2, both of these are a problem. We can't have either one of those because we can't take logs of negative numbers. So negative 2 doesn't work, we just get 5. Check for extraneous solutions there. Go ahead and try this one. Again, we're going to combine these into one logarithm. So I'm going to have log of 6 divided by 3x equals negative 2. When we have subtraction, we combine them by dividing. Simplify here, and we get log of 2 over x equals negative 2. Again, we have a variable in our logarithm, and the only way we can solve that is by switching to exponential form. So 10 to the negative second power equals 2 over x. 10 to the negative second power is 1 over 10 squared, which is 1 over 100. And right now we have proportions, and in order to solve proportions, we cross multiply and set them equal to each other. So we get 100 times 2 equals 1 times x. So x is going to be 200. If we plug it back in, it will work just fine. We'll have a positive 600 there. So we're okay. Real quick recap. Logarithms can be used to solve exponential equations. Exponents can be used to solve logarithmic equations. So if we have a logarithm with a variable in it, we have to switch to exponential form. If we have an exponential equation with a variable in our exponent, we've got to switch to logarithmic form. Have to switch from one to the other in order to solve. And remember that the exponential function y equals b to the x power and the logarithmic function y equals log base b of x are inverse functions. Here's the assignment, and we'll work on that in class on Tuesday. Thanks.